So, hello everybody. Welcome to our fourth Circular Strategy Symposium. I will guide you through these next 2 days, today and tomorrow. My name is Karin Raith, and together with my colleague Lukas Allner, we curated and organized this symposium. Originally, I wanted just to be part of the auditorium, to lean back, relax, and listen to everything what was said here, since I am recently retired from the Angewandte. But then, unfortunately, Doris Österreicher, who was supposed to do the moderation, fell ill, and I had to step in. So I will be your moderator for the next 2 days. First I will give a short introduction into the structure of these 2 days. We have usually all the symposia deal with sustainability, with circular economy in architecture, or with future-oriented architecture on a more broad basis. But this time we chose a specific focus, which is architecture and the biosphere. Lukas Allner will give a brief introduction into the structure of this symposium a little later. And now I would like to welcome our new rector, Petra Rinkel. I think she's in the office for 12 days now. And I'm very happy that she agreed to open our symposium. Nice to see you there, and please proceed. I think you have your own microphone.
So, good afternoon. Dear conference participants, dear colleagues, dear guests, on behalf of the Angewandte, I have the honor to welcome you here in Vienna to one of our wonderful buildings, but unfortunately, maybe we haven't yet integrated the biosphere. So we don't have that much sun here, but it's a wonderful building, and I hope the ones of you who don't know it will have the chance to see it a little bit more. We are all very pleased to have you here, that we can welcome you here, and that you will address a topic where I think it's in the very core of what Angewandte is all about. I have, as Karin Raith said, been rector of this fantastic university for just under 2 weeks now, but I learned straight away that this is already the 4th symposium in a series of symposia. Therefore, there will be many of you will know much more than I do, how this topic of circular strategies in architecture has developed. Okay. How this topic has developed and what contributions this series of events make to the topic in architecture. The discussion about climate crisis and about, I think you all agree, strong sustainability is particularly evident in the place where the cities and infrastructures of the future are conceptualized. And I think you are this community to do this. Therefore, the symposium's question of how to integrate the biosphere into the technosphere of architecture or the city in order to overcome the climate crisis is one that connects the topics of the Institute of Architecture with very essential questions of the University of Applied Art as a whole. Why? Because for the integration of the biosphere into our designed environment simply also means that we have to develop a new societal relationship with nature. for the integration of biosphere into our designed environment. And the future of this societal relationship to nature, I think it involves a really different perception of the world. It integrates a new way or new aesthetic, new ways of dealing with topics, and especially new modes of production, and that also new ways of imagining, exploring, inventing and producing our material and symbolic objects. And it is precisely these practices, the critical questioning, the imagining, the speculating, the exploring and the inventing that make up an art university and especially the Angewandte. In this respect, there is a great interest in this exciting symposium and the impulses that come from architecture in this field of circular strategies, impulses for the arts, the sciences, technological developments. And so I wish you and all of us exciting insights into the field of circular strategies and how, and I think that's exciting, the most important thing, how we all can do something about to integrate the biosphere into architecture, into the city, and into our future lives here at the Angewandte, in Vienna, and elsewhere. Have a good time and enjoy this symposium, and thank you.
Thank you for these encouraging opening words. I remember that you said quite a similar thing in your inauguration speech and at the hearings, so that if I remember correctly, that it's not the task of a university to train students for the given economic and social situation to cope with all the problems, to be successful in this situation, but it's a good university should be able to give them space and time to think ahead, to think critically, and to shape, to envision, and to design a new, better future. And so I think all the persons that we invited for this event are persons that work on this task, who try to envision, shape, and design such a good future. And so in this sense, I'm very much looking forward to all the interesting contributions. And now I ask Lukas to the stage to give us a quick overview of what will happen today and tomorrow.
Thank you, Karin. My name is Lukas Allner. As Karin has mentioned, together we have been curating this event for the fourth time now for this year. And this series has been dedicated to discussing ideas about future-oriented built environments. Future-oriented in a sense of the ability of architecture, cities and buildings, to renew themselves, to adapt, to transform. And some reasons why we should do this, and some examples of how it can be done, and some thoughts about what it means, and also what opportunities could arise from such practices we have seen in previous editions of this event. And we will probably learn about some more today and tomorrow. Now, it is no coincidence that some of these notions mentioned before, such as renewal, adaptation, can also be found in biology. Sustainability, for example, is a term that originates from forestry, from the 18th century. And nature performs these mechanisms in perfection. This is why this year we have decided to look at the intersection of the biosphere with architecture. We want to look at in this series, or in this very event, We want to look at the biosphere as a model for inspiration and as an example, but also as a resource for materials and as a participant. So the symposium is structured in 3 blocks: materials, ecosystems, and transformation. In each block we have 2 speakers coupled in a dialogue session. We have the 2 of such dialogue sessions before we have a panel discussion with all 4 speakers of the respective block. Now, before we start with the first block, materials, and our first speaker, I would like to invite you to our small poster exhibition outside in the atrium, which showcases selected student works from the Institute of Architecture here, projects that relate to topics addressed in circular strategies from the past, from recent years. So please have a look in between the sessions or after the event. And then lastly, I would like to bring your attention to the program booklet. In here you will find some background information about the speakers and about the schedule, and you can use the booklet to take notes. This is new. And you're all invited to send us back a picture of your notes after the event if you want, for feedback. That would be nice. So with no further ado, I would like to hand back over to Karin to introduce our first speaker. And I wish you all a wonderful symposium. Thank you very much.
Yeah, as Lukas said, we now come to our first lecture block, which will be about the topic of material. What opportunities do nature-based building materials offer in terms of decarbonization, resource conservation, and the creation of healthy living spaces? What is their design potential? What are their limits? Of course, wood plays an important role among the natural organic building materials, and if it was available in abundance, it was used for millennia. And therefore, the first section of the lecture block will be about wood, and we have invited 2 personalities who both work not exclusively, but primarily with wood, with timber construction, and they are very different in their approaches to this field of work. At least that's what we believe, but let's see. Let me quickly introduce Thomas Mennel. After completing his studies in architecture at TU Wien and acquiring extensive knowledge of wood construction at Hermann Kaufmann in Vorarlberg, that's a renowned firm, I don't think that I have to tell more, Thomas Mennel is now the managing director of GBD projects in Dornbirn and a specialist in facade planning. On the other hand, he and Reinhard Muxel work on smaller buildings, projects for cultural initiatives and design objects, always in close cooperation with experienced craftsmen. Thomas has researched traditional timber construction in depth for many years, especially material applications, processing methods, and the evolution of local house types in the Bregenzer Wald and Montafon, 2 regions in Vorarlberg, Austria's westernmost province. And based on this research, he has developed a distinctive practice of restoring and reviving historical buildings while adapting them to today's demands and requirements. Thank you for being here. I'm very much looking forward to your thoughts about timber construction.
Okay, thank you for the invitation. Heritage of building construction is for me one of the most interesting things, searching for a solution, even for the future. So I still keep on working and my approach to historical construction. And that's what I want to show you. It's all about low-tech, it's about reuse, it's about renewing buildings, but not only in thinking of reusing in the type of reuse the materials or the building parts. It's more about the ideas that lays behind these construction types which forefathers developed years ago. So I show you first some images of building, and to show you that by using the construction itself, by using ideas of the construction types of flooring, of ceiling, of materials, that we come to new solutions, and the combination will be the interesting part. So I have to show you a lot of pictures, because I think only the practice of reusing the things and adding things new can show that the combination will be an interesting model for the new future, for a future not only in using this material, even in using the ideas and the combination. I'm convinced that the surfaces of these materials and the surfaces of the materials and the connections, the low-tech approach, the few construction connection things we need for this will approve new design and will be interesting for each other to find a potential in these kinds of things we find. So I show you combinations of materials and development we did with craftsmen, and these craftsmen were very interested to do this because of the research I did before. I could show them always things which they didn't know either, because the last two generations, my father's grandfathers, even lost some things, and we could show that there would be interesting solution even 400 years ago. So the main approach is about dendrochronological studies. One colleague of me, Klaus Pfeiffer, do some studies in this kind. He works on this for 20 years, more or less. And so we did in common a lot of research in buildings like this. So we can explain what happens in a building like this. There are more or less 3 or 4 renewing steps. And these renewing steps always are development of the craftsmanship, of new needs, of the demographic development of the culture. And so we can show that in one of these buildings there are more or less 3 steps or 4 steps in the Bregenzer Wald. That's a common strategy to renew and to use the old construction by overwhelming it with new possibilities of technical approach. So if you see this comparison at the left side, for you it's the 400-year-old shape of the beginning of the house, and the other one is 300 years later. 400 years it was when we researched about, but the design is more or less 100 years old. So in between these two designs there are 300 years of different interventions they did. Here the next step, it's if you know the culture of building in the Bregenzer Wald, at the end you find housing like on the right side. That's the typical image of a Bregenzer Wälder house, but we developed or we searched for the background of this thing, of this behind of the timber surface, and we found out, if you look, you can find the different steps of additions. The lower part is mainly the same as and on the left side. Then on the right side there is an adaptation which was added by steel clamps, and at the end it was the huge new roof which was put on. So this kind of renewing, reusing is very typical for the region, I think all over the Alps. So on the picture you see a very young example where the same was done, where only the cellar was renewed and the old structure was kept above to do the new cellar below. Yeah, there is a lot of tradition in this. So I was doing some objects in the same way. So I will show you now some examples of this, but not to talk about the heritage and the respect, even more that these structures are or give the possibilities to find solution, to renew and renew the solutions, or to find or interact with these solutions to create new spaces, new constructions, and even new surfaces and all these architectural approaches we need to develop. Here I show an example I did a lot of years ago. You see the renderings we did, early simple renderings at this time. Here you see the ground floor plan with the kinds of renewing parts of the parts which would believe and which we would create complete new images for the whole house. So you see that we could do a big roof, glass top, and such new things, and created completely new images of spaces, new surfaces, and so it's worth to work with the structures. I think that's the interesting, even to deal with tiles. We did a new stove with these tiles, and we combined all materials in a very assembling and easy character. So I think it's worth, or it's the main option to practice this. You have to really search for the main characters, the parameters of the materials, and you find the solutions, as Yves told by the construction view. I think it's also in the view of the surfaces very interesting to keep them, to re-engage what the forefathers thought about in using these materials. So this is a sketch. I do a lot of things in this kind of planning, not in the facade planning, but in this kind of planning, I do a lot with sketches, because if you have shifted walls and all like this, it isn't important to do it by computers. It's more to practice how you discuss this with the craftsmen. How can you get them to achieve the main solution? We do analysis for sure. We have to do, like it's called Energieausweis, U-word, how is it called? These calculations. So we don't hide from this kind of things. Either we try to do calculations. We try to show that it will function in future even too. All this moisture stuff, moisture barrier, and all these things we try to avoid. So we think that the wooden trunks and the massive wooden walls could keep these things out or have a good transport for all these moisture things. Yeah, now I come to the house I did for my own. It's a typical Bregenzerwälder house, farmer house with a barn at the back, and the front house is the living house part. It's all under one roof, and we had the chance to buy such a house. The part in the front, for the living part, had one family, and we could add things in the barn in the backside. So we did there a house-in-house concept because of the construction, which was more or less 150 years old. I didn't want to go to the walls. I didn't want all the physical problems at the construction, at the wooden construction, so I did this house-in-house concept. Yeah, we did at the end 3 flats inside 3 apartment parts, one at the front part, one at the attic, and the third one there where we live now in the back in this barn. Yeah, I show now some images to show you that it would be very inspiration process to work with these sites, to have the rooms, to have the space under a roof with huge spans without any columns and like this. This is still old. This is not new. So we could do very free planning inside of the things, and the children still liked it. They were allowed to do a lot of things which normally is not allowed in these rooms because they are very rough and very easy to treat, and even to clean it's not that problem. So at the end of this part I show you that it is also added by new parts, steel construction, glaze plates which are reused, which I could buy, and so I had to do a new second construction in front of the construction of the wooden barn. Well, I will show you now a main part of this project, which was the development of a wooden roof plate system, which I found in all the houses about 1600. All these houses have the same roof type as I did here. It got lost by the craftsmen, by the carpenters, and we first did this 10 years ago. We tried the same construction type, with which we could call a strained board roof. It's about a conical board which is put into the part. It's important to read this sketch. You see there, I did the signature to this part which is conical, and this is the final part you put in. So you had to push it in at the end, and so it will strain itself. This is this 400-year-old technique I found out in the houses. You see the example up there. This is this part of board, of conical board, which you find in all alpine types of block houses, of wooden block houses. This is very typical even in Switzerland, in France, in Austria, in German. It was a well-known technique, but it got lost, I think. And the carpenters of my father's generation didn't know this technique or didn't use this technique. And we started to do this in my house because I wanted to show that this still can be reactivated, this technique, and we can show that it would function nowadays too. Yeah, so it's a big amount of knowledge. What happens by a strange board flooring? So it's too much to explain, but you see that we thought a lot of what happens, what has to be done by the craftsmen to come to the same solution as the people 400 years ago. Yeah, and so we searched what would be the advantage, and we found in old books, and they still are the same, the same knowledge. If you use these trunks in this way, it's like Eve told. if you have the annual growth structure in a good combination, it's much more stringent, and so you have 20%, for example, more forces you can load if you use the wooden trunk like this. I think it's nearly the same idea, but 400 years ago, people were thinking that it's good, and so we tried to do it in the same or in a similar way. You see it now at the flooring below. It still is there. You see it still as the conical board, which we pressed in. At the end, we could strengthen this whole floor a lot. We did one thing different to the 400 old technique. We didn't have a wooden frame. We did a steel frame, which was much more effective. So we expanded, we strained it in a steel frame, and it's for me it was like the carpets laying on small columns. Yeah. So we did a lot of construction renewing, always in kind of low tech and with, for example, wooden nails instead of screws, of steel screws, because you can show in this that the thickness of these wooden nails would be as the same as 20 screws. So it's low tech and simple technique. If you have the right carpenter, you can do this anytime. So I used a lot of things which were in the house or which were on other sites being thrown out. So there is a church floor at the right side. There is the staircase we reused. And these are all things we didn't use any screws or something like this. They are only leaned on the walls, and yeah. We did a lot of this stuff, and each decision was to know what would be better. I'm not against new solutions, but if you know what a natural stone wall can be different to a concrete wall, you know that there the moisture in, out, and all these things are very much better. So if you have a concrete wall, it's dead. It's still mass. And if you have a natural wall with plaster, there is always an interchange of humanity from the inside to the outside and all these things. So there are advantages. So you have to decide what's the advantage. Even there are disadvantages. It's not allowed on historical architecture or historical kind of solution, but it's the respect or the comparison. What's better? What could be good for the new use, or what is not good? What have to be changed? Yeah, and so I did a lot of using of materials, but also of ideas. So I want to tell you, it's not a backward thinking. It's even more to learn about the things by researching, by the approach of historical architecture and building solutions, so you can use it and give them new adaptation. This is enameled surface. A lot of Stoven had this surface in the more or less 150-year-old tradition of making this kind of surfaces, and I did it for a special function in my kitchen or in our kitchen, and I did even such things. Not only in wooden materials, we searched and found out that there are a lot of solution laying in the back, which only has to be refreshed. Yeah, and so it's go on. It's not important, I think, but the main thing or the difference to Eve maybe is that I work a lot with material at specific detailing and the interpretation or the using of the materials in a more or less rough and low-tech idea. And this is where it's normally is very interesting in this discussion of CO2 reduction and all of this, here you don't find a lot of materials which need a lot of CO2. So it's always interesting to get such spaces with low tech and simple solutions. Yeah, these are the examples. I'm not afraid to do other things. It's even other projects I do in a similar way. So I think we can come to solutions and to look for ideas really in our historical building equipment. And there are a lot of ideas laying behind, and we only have to think about it and to refresh what could they thought or what could be behind when they did something. And that's the very interesting I'm working on, and yes, that's my opinion and my part for this section.
Thank you very much, Thomas. At first glance, it seems to me that those two speakers have a lot in common. So both of them build upon the research of traditional craft, and then they apply this knowledge that they gain either in a low-tech or in a high-tech way. But of course, there are also differences, and I'm very much interested then in the discussion panel that we have after the next block of two speakers, that you exchange ideas about this issue. But first of all, I would like to ask the audience, are there any questions you want to ask immediately? If there is a question to you, could you please come up again to the stage?
Yes, it is a question for the first speaker. I would like to, you talked about the jointing of the wooden plates. You did not mention, however, I'm sure you know about it, that in Japan, this jointing, which is known as Omegushu, or it's in German it's called Japanische Zinke, which uses a very complicated, at the same time simple way of jointing that you can only joint in one way, and so there cannot be any mistakes. So you know that most of the people who work on the building site are complete idiots, so most of the mistakes are made on the building site. That can be eliminated by this method, and I'm surprised you didn't mention it. Thank you.
Well, I try to be short, but of course, insertion vectors I mentioned, and what you are referring to are insertion vectors. And what's so interesting is that in the Oriental background, insertion vectors are not in the orthogonal Cartesian frame. So we think very often we insert something like this, being in an orthogonal frame. And for example, there's a shrine in Japan where they have an insertion vector like this on the edge. So this is very interesting because it's, as you say, you can only assemble it in one given way. And Christopher Roberler's thesis at IBOA, published 2015, is inspired by insertion vectors, and he calculates the insertion space for 3 different panels which are positioned in space. And he's calculating that on, let's say, on another level. So it's clearly, but I couldn't do this, I'm sorry. So.
This goes to Yves. So my first question is, like, you shortly mentioned that the wood market is distorted, and it would be interesting to hear a bit more about that. And the second thing you mentioned, that disposal of wood architecture is sustainable, and I was reminded of a conversation I had with Dietmar Eberle, who told me the opposite, that it's a bit of an illusion that wood architecture in its afterlife is sustainable, and I would like you to comment on that.
Well, I don't know exactly. I mean, when we turned to roundwood, we really believe that you could get very far with this, and that you have a very simple construction method. And when we look at buildings which have been built 50 years ago and which we have to dismantle now, those wooden structures are composed of several layers. It's very difficult to restore, to recycle them. But this is not more the case today. So I think if we move to more simple construction, where, for example, massive wood, as in trunks, it doesn't correspond to the usual optimization of a structural engineer who gives a minimum section. We can give larger sections because it's not very expensive. So the logic is opposite. So I think the construction logistics has to change. About your first question, I tried to explain that we are going to try to do this for Switzerland first. And the whole market is distorted. I mean, how can I say this is not only the case for timber? And what we are trying to do is, for example, to create local circular sawmills. We have still in Switzerland 700 sawmills, which employ 3 to 4 people, and which could extend their business plan to other types of fabrications and technologies which are not that expensive. A robot costs 180,000 euro, something like that. So it's not such an investment to add to the usual business they do as a sawmill, also other techniques. And I think this could be developed much more. But it is true, if you think economy in terms of large contractors and bidding companies, they are keeping their own logistics the way they want. And that's the difficulty we face. So, and of course, you showed lots very interesting about refurnishing. I mean, 70% of our housing stock needs to be restored. So you are in a very important part. But the architects don't speak so much about it. They speak more about the new buildings and things which are done from scratch. So there's...
I have a question to Thomas. You showed that Bregenzer Waldhaus, that very old building that has been transformed many times. Is it because of the special arrangement of rooms, of the special structure of the house that this is possible? Or is it because of the ability of the craftsmen to handle this type of houses? Or is it because of the material? What's the reason for the ability of these houses to transform and to be modern for nearly 500 years?
Yeah, I think it's the core. The main thing is the core. It's a 3-room core with the heating cell in the center. So it's a very intelligent kind of rough structure. And this made it possible for the next generation to deal with it. They often cut it out, new doors, new entrances and all these things. So they worked in the core and they had the ability to add things at the outside. As I showed in one picture, the outside parts were things to do Getreide. Corn, yeah. The region was even a corn region before 1600, and after this, the Greenland force for cheese and cows came to this region. So they differed, and the background, because of the closing of these outer parts and the the growth are that there was a kleine Eiszeit, a small, it's called the kleine Eiszeit in the medieval ice age at Mount Atif in the end of the medieval. So they closed their houses more and more. So if what you saw is what people naturally do, and the structure was that strong that they could do it. So it was a good core with good wooden trunks. After this, they had even, the wood wasn't that good. All adaptations, all additions weren't that good because the wood they cut it after this was a rapid growing. The old one was the real standing wooden thing that was really in a small growing process, and the other ones with a lot of light grew very much faster, and so the newer parts are not that good as the old ones. That's very interesting. So you have even to decide which kind of timber growing distance one trunk has. So the research you did depends also in this kind of what growing happens on a local place, and it differs. And so the core was the strongest thing. All the housing in this region is more or less from the same age. Yeah.
Okay, thank you. We will now have a break. If there are more questions, you can ask the speakers in between, but please give them a chance to grab a coffee. We meet again at 5 o'clock sharp for the next session. Thank you. So the next section of the lecture block material will deal with nature-based and natural material and material experimentation. And for this, I would like to welcome Petra Gruber on the stage. She is my successor at the Department of Building Construction at the Institute of Architecture at the Angewandte, and head of the Department of Building Construction now. Hi, Petra. Petra Gruber is a researcher and educator in architecture and biodesign. She holds a PhD in biomimetics in architecture from TU Wien. She has been working on 3 continents in inter- and transdisciplinary design, research and education, and at the intersection of biology, architecture and art. She was a research fellow at the Center for Biomimetics at the University of Reading in the UK, and held a visiting professorship at the Ethiopian Institute for Architecture, Building Construction and City Development in Addis Ababa. Until 2020, she was an associate professor for biodesign at the Biomimicry Research and Innovation Center at the University of Akron in the United States. Her research on spatial and functional aspects of biological structures for biomimetic innovation in architecture and the built environment has been published widely. As I already mentioned, on the 1st of October, she joined the Angewandte as a professor and head of the Department of Building Construction. So I'm very much looking forward to your report on your research and your thinking, and yeah, let's go ahead.
Danke, Karin. Thank you very much for having me here today. I'm super happy to be here. So it's also my day 12 or something at the Angewandte. I'm very happy to continue my academic venture here at the school, where I have carried out already 3 research projects that I found so grandiosely supported that I'm really looking forward to the next years to continue my research efforts here. So my talk today is called A Living Architecture. And this is a title that I really was fighting against for a long time, because I work at the intersection of biology and architecture, and I started that from pure interest in biology and design. So these are my two passions. And I was very happy when I did my diploma at the TU in Vienna that I discovered this field of bionic, which is a strategic approach to learn from nature or biology for technology. And I did a PhD in that field. And due to my background in biology, I was always thinking, no, architecture can never become alive. And times have changed. So since I completed my PhD and published it, things have kind of expanded in a way that I'm no longer sure about this. And so I started using this also as a title for my talks. So today I will talk a little bit about the whole bio thing that is emerging. And we have come across so many different approaches that I call this chapter Bio What. So I want to talk a bit about terminology and different aspects of this big field. Then I want to clarify the term material systems, because I think it's important to look at that to derive innovation from biology into technology. I will present you with a short review that we did with some colleagues in the field. And then I want to present you one case study out of my work which deals with mycoterials. Some of you might say, okay, fungi, materials, we know about this. But I really want to show you how things work when you start from basic science, fundamental science, and go to material systems, and then really try to work with engineers, do all the testing and all the challenges that arise with such a kind of experimentation. And so my field as of now is what I would call biodesign, which is a pretty, a rubber band-like terminology. So it kind of boils down to this narrative that we have impacted our environment on a very global scale. We'll know about this. I don't need to talk about that. And besides technology that brought us here, actually, biology is the only other model that we have on this planet. So we need to look at nature to design for a sustainable future. There's just no other way, in my opinion. And for me, my approach when I did my PhD was to look at the terminology of biology and to look at categories of biology and use this filter to look at architectural design, which is not what most people do. So most people look at biology with these filters of engineering. So they look at, for example, shell structures or things like that. So what I did was the other pathway. So I took those, what I called signs of life of architecture, of signs of life of biology, and projected them onto different scales in architectural design. And what I found out in my thesis is that there's already many fields that are covered, and there seems to be an interest in all fields to take on those signs of life for architectural design. The reason might be that nature provides us with very, very interesting materials and systems. So they are really very adapted, responsive, dynamic, differentiated, and so on. And what we're seeking is to have those features also in technology and in architectural design, and specifically also in materials. So I don't want to go through this whole list. It's just the important thing is that this framework is still important for my work. So it's been there since for myself since about almost 20 years now, and it still functions as like my guideline. And defines also very specifically then what goes on in architectural design with interaction with the environment, water cycle, thermal management, generating space for living systems, and so on. So it kind of boils down to the very detail. Coming to the bio what. So what you see here is a range of those terms that kind of surround us. So we talk about biomimetics, biomimicry, bionics, bio-inspired, and so on, nature-based, bio-based, biomaterials, and lately we talk about engineered living system, living materials, and living building materials specifically. So all those terms have their specific notions and have also a history. So biomimetics is something that came up, I would say, in the late 80s, and is about transferring information from biology to technology. So it's a generic innovation method that has been used in very different fields and disciplines, starting with probably electronics. Biomimicry comes from the US and integrates a whole philosophy and a lifestyle approach as well that also deals with the urge to have a more sustainable future and to design with nature. And this is also integrated into this innovation methodology. That's the very specific thing I would think about biomimicry and so on. So I don't want to go through all those terminologies with you. So it's important to see that this field is really rapidly expanding, and different people develop different methodologies for their work, and there's a lot of methods and tools out there already. So my approach was rooted in biomimetics, and I have kind of moved on also integrating organisms into my designs and working with organisms growing materials. So I have kind of extended my own field beyond just the transfer of information, but this is still a field that is very dear to me because I think that's where we can learn a lot. And now I would like to jump to this other term of biomaterials, material systems. Why I want to talk about this is that I talk in front of an audience coming primarily from the arts and from architecture and technology. And we have a notion of materials as something that is very, very isotropic, it's very small, so we think about it of metals or plastics. It's something that has very strong coherence on all levels of scale. Biology doesn't function like that. We have building blocks, and then on every scale level, there is a hierarchy of structure. And most biomaterials have structural levels on at least 6 different layers. And those structures are very, very different from each other. You just see one example here, which is bone. I could have taken anything. I could have taken wood or bamboo or, any kind of biomaterial derived from living systems, exhibits properties on many, many levels of scale. And that's something that we have not yet exploited at all in our technical materials. So I think that the design space for materials is actually going down to the nanometer scale. And it's usually not something that we as architects touch, but we can to a certain extent if we collaborate with other disciplines like biology, microbiology, materials, engineering, nanotechnology, and so on. So it's something that we should be aware of. And this is the reason why we call those materials not just biomaterials, but very often material systems, because they are actually not genuinely boiling down to a specific chemistry, but are characterized by those different strategies that are implemented in those different scales. And I want to quote 2 people here, Jim Gordon, who worked at the Center of Biomimetics in the UK and was one of the founding fathers of biomimetics. He said, structures are made from materials, and we shall talk about structures and materials, but in fact there is no clear-cut dividing line between a material and a structure. So he was talking about biomaterials. And then another quote by a person who was famous for biomechanics, Rick Huiskes, and he says, if bone is the answer, then what is the question? And this points out one of the challenges that you face when you look at biological materials, that it's very hard to define the primary function of that material because it always fulfills a wide range of functions. And so it's very, very hard to interpret. And so this quote comes from the very person looking at bone as a structure, for example. So in the review that I recently did with my colleagues Natasha Jayamour from France, from the CNRS, and another colleague, Valentina Pericone from Italy, we made a review of materials that have been developed with all those approaches. And
we had a very hard time ordering the field, and we resorted to take 3 of the main terminologies: bio-inspired, bio-based, and living materials. And we tried to sort our findings into these 3 different bigger blocks. I see that as a current effort to do this. We were not completely happy with it, but we also couldn't find a better solution. I think this is a field that is still so rapidly developing that other terminologies will probably be coming. So bio-inspiration refers to an innovative design process inspired by biological strategies. So this is really about information transfer. And the one example that I randomly took here is a building facade that actually takes out pollution from the air that was built about 10 years ago in Mexico City. So it's like an active building component that actually negotiates between the outside and the inside. Then bio-based is a material whose main constituents consist of 1 or more substances originally derived from living organisms. So bio-based materials is probably the most interesting piece of category in this framework of this symposium here. And what you see are kind of bioplastics that were derived from marine substances. And the last category is living materials, and we think of this as materials that are actually alive, and we have those. We are starting to have those too in architecture, but it's essentially material systems that possess unique advantages of biological systems, such as, for example, self-sustainability, self-repair, self-replication, biosignal responsiveness, and usually by integrating actually living components into the material, which are usually like microbial systems. So this is something that is pretty new. So we have many research groups working on things like that in all fields, like paints, like algae facades that you see here. So there's all sorts of efforts to integrate living systems in our architecture domain. And using this framework, I just want to talk about one of my research trajectories, which is the mycoterials, as we call them. It's materials that were generated due to the growth of fungi, of mycelium, and uses the mycelium as a binder. So what we are actually having here is a composite material. So we have some kind of organically derived substrate that is usually a loose aggregate. For example, wood chips, could also be paper chips, it could be straw, it could be hemp, it could be flax, anything that contains cellulose, and uses fungi to grow through it, and by this growth generating a lot of tiny root material, and this tiny root material that we call mycelium solidifies the aggregate. So what we're actually doing is we are taking something that is no longer of use. It could be agricultural substrate that is just a throwaway thing, and we use the fungus, let it grow through, and suddenly arrive at a building material. And what you see here is just a very aesthetic, pleasant view of one of the surfaces. This is actually something that we don't really want in the material production, which is the fruiting bodies. But they have their own aesthetic value, so we were also kind of interested in this too. So it's something that material scientists wouldn't like to see, but as architects and designers, we always play at this kind of interface. And I've worked on this for quite some time. What you see here is a like cross-sectional study of what is out there. So we actually have a lot of build stuff there, prototypical buildings that different research groups and people have generated in the last 15 years, I would say. Different constructions, so you see walls, you see like towers, you see like frameworks and shells. And these buildings try to understand what we can do with this fungal material more or less successfully. And I have worked with this material for the first time at this school in one of my research projects that Barbara Imhoff, my dear colleague, co-led together with me. And those projects were funded by the Austrian Science Fund, FWF, and happened in the framework of the PEAK funding, which is an artistic program. So we were free from the forces of product development and could really play around with those materials, trying to understand how they could push architecture further. And one of the first things that we did in this project was to understand how could we generate molds that could lead to architectural outputs. So this material is actually like a plaster, so it does not give you a shape. So you can generate this material in any shape you want, which means you need to preform something. And we played around with baskets, with solid forms, like the next picture. So this is a 3D printed shape where we grew mycelium in. And you see again here this very interesting fruiting body that came out of it. And we also tried to use those scaffolds where we put the material in to generate shell structures. So this was again another strategy to shape formation. And in the GRAB project, Growing as Building, we managed to generate a range of like small prototypical examples of those architectural models. So when I had the chance to continue this research at the University of Akron within the frame of the Integrated Biosciences PhD program, we decided to enlarge those efforts and scale up to architectural scale. And we were courageous enough to try to produce those panels in architectural size and explored mycelium as a building material for building facades. We collaborated with a local architecture office, Red House Studio. Chris Maurer is the head of this. You see him on this picture here, together with one of our undergraduate students in Akron. And we did those large-scale experimentations in one of his workshops in Cleveland. And we tried many things at the same time, which was probably not the smartest thing in terms of science. So we played around with different substances. So we used corn stover, hemp hurd, flax, sawdust, soy hulls, all sorts of materials. We played around with different methods of sterilization to avoid the growth of other organisms, which is one of the biggest challenges if you want to grow something, is avoid growth of something else. This is a nightmare. So one of the biggest issues we had was contamination. And so the third thing was to create those growth environment with different strategies. So we used like frames, we used tents, we used boxes, all sorts of things. They worked differently, badly or well, so you will see those later on in the pictures. And we also used different post-growth treatments. I told you about the living organisms embedded in systems, but when we use fungi, we are confronted with the fact that those fungi grow fruiting bodies and then finally produce spores. This is not something that we want in an architectural environment where people live. The spores could be not beneficial to health. So what we actually want is to kill the whole system before we bring it indoors. And this can happen in various ways. So we can dry those panels, we can bake them, we can also compress them to consolidate the material, and we can use both. And we can use a coating to cover the materials so that nothing gets out, that they are also waterproof and weatherproof, finally. So we played around with all those variables. Some of those experiments were successful, some of them were not. And we also tried to apply that in an architectural context. And again, very courageous, we decided to make an outdoor experimentation on a small setup that we put in our field station. So the advantage of living in a biology department was having a field station and being able to use this space also for those outdoor experiments. We used that also for other prototyping that we did. So you see here also those ceramic tiles, which refer to another research avenue that I don't want to talk about today. So you see here the outcome of the LIVAS project that was funded by the university with a small grant. And we tried some of those improvements of growth conditions, different treatments of the panels. So we had like raw panels with interior grid to reinforce the system. We had compressed panels. We had baked ones, we had both systems, and so on. So we used this setup to look at long-term performance, outdoor performance of those mycelium panels. And we did this not with a very clear perspective on what we wanted to do. It was just a study that nobody had done so far, so we couldn't get any literature on it. That's why we decided to just try that. And so the purpose could be manifold. It could tell us what we could then use as a strategy to really generate long-term performance for those panels. But we could also think of using this material as something that is applied and then purposefully is allowed to degenerate and then is only here not on a permanent base, but maybe as a temporary measure for certain purposes. And we were also interested in the settlement of living organisms on those panels, which I have to say was not very successful due to the fact probably that the rhythms of drying and wetting were just too harsh for most organisms to survive. What you see here are photographs from different time zones. So you see after 5 days, after 118 days, after 236 days, and 622 days finally, you can see that most of the panels after almost 2 years have completely disintegrated and didn't leave anything behind but a small heap of sawdust on the bottom. So it's something that really vanishes in the environment as it disintegrates, which is also an interesting observation. And we can also say that the mechanical performance, pardon? Really? Oh, I'm sorry, I have to go much faster. So the mechanical performance was really well for the first few months. Okay, we have to jump. So yes, let me jump over this discussion. We also used this for aesthetic pleasure. So we put one of those panels in a faculty exhibition, and this was a really huge thing that also started to generate fruiting bodies and created a unique smell in the gallery. So this was something courageous. We did this before anybody realized that there could be spore contamination, and we took it down before we saw spores actually coming down from the fruiting bodies. And we had the luck, or the due to these first efforts, we generated funding from the USDA to make a really extensive study on the mechanics of those materials. And you see some of the imagery from the lab there. We again collaborated with Red House Studio for these efforts. We produced countless cylindrical samples for materials testing and countless rectangular samples for bending testing and impact testing. And you see some of the procedural activities here. This work is all published, so I put some of the papers on the slides. And our interest was to understand also, again, on a more scientific basis, the post-growth treatment, again, improve the growth conditions, and then also get hold of the mechanical characteristics of those materials. And here again, some of those assessments on the way. Interesting also the harvesting. So we also looked at the fruiting bodies that were harvested during that time. And finally, the compression testing results. And you see that they differ according to the treatment and the growth conditions, and also the composition of the substrate. So this is all published material. So if you want to continue this research, you're welcome to download all this and get the reports from me personally to continue our efforts. And you can also see that there is no, in the compression testing, there is no such phase like complete collapse. This is also interesting. So this material does not collapse. It's a material structure, and it has a certain elasticity and kind of bounces back. So there's a certain hysteresis, as they call it. So it's not something that usual building materials exhibit. And so we kind of had some major findings. So the density correlates with compressive resistance and so on. So there's some kind of major statements that we can make. But in general, you have to really look at the boundary conditions to tell something about the resulting material. We also embedded this in an existing framework of circular use of mushrooms, like producing mycelium-based materials in this cycle that was published by Paul Stamets, one of the fungus gurus. And so we added an extra function to his piece. There's many other research groups active in the field, so working on different challenges. So the Bristol Unconventional Computing Lab around Andrew Adamatsky works on the sensing capacity of fungi. So they want to discover the language of fungi. The electrical signaling is kind of transmitting information. So the visionary idea is to use those fungi also for information technology. And the Royal Danish Academy is working on the mechanical properties and structuring. And Chris Maurer from Red House is working together with MIT with a huge facility in Namibia that they call the BioHab project. And they also want to use this for space exploration. So it's very exciting stuff coming along. Okay, and then very quickly the challenges, inter and transdisciplinary work, working with other disciplines, complexity of biological material structures, maintaining the lab environment, I already said that. Scaling up to production is maybe the biggest issue, lack of standards and new production processes. As I said, there's tons of publications out there. Among them my own, so you find everything on ResearchGate. Let me just jump over this too. And my mission statement, which is expand the design space, not only to nanoscale, but also to take on the opportunity that we as architects are trained to solve wicked complex problems, to also go into biological, social, cultural, and political questions with our domain. And with this, I want to thank my research groups, my collaborators, the institutions that have hosted my work, and I want to thank you for your patience and attention.
Thank you, Petra. We see that you're really flowing over with knowledge and with enthusiasm. But there will be more time to expand on that in the panel discussion.
Thank you.
Thank you. And I ask our next speaker to the stage, Cooman. His focus is on a different material, not an organic material, but also material from nature, inorganic material. He will tell us how he deals with this kind of resource. Ken came from us from Brussels in Belgium. Welcome. Ken de Cooman is a co-founder of BC Architects and Studies in Materials and a research associate at the Act of Building Junior Professorship in Civil Engineering at the Rheinisch-Westfälische Technische Hochschule Aachen. He holds a master's degree in philosophy and architecture and is a diploma candidate in psychology, so an extensive educational background, I would say. When he started his professional career as an architect, Ken focused especially on earth construction with several projects on the European and African continent. Today, he is delegated director of BC Materials, head of development and consultancy, and responsible for the quality control of resources and products. Nice to have you with us, and I'm looking forward to your presentation.
Thank you very much. First of all, thank you for the invitation, and also thank you to the other speakers. Already very interesting topics that that were touched upon, and I will elaborate from our experience, because it's not me, it's us who is doing things in Brussels. And I come from this collective called BC. which exists from three entities, three legal entities. And this already points a little bit to the fact why we need to, or what we're doing, what our approach is. I would say we're a hybrid practice, and we have an architectural office which is called BC Architects. We have a non-profit organization who organizes education, publication, lectures, and so on, which is BC Studies. And we have a material production cooperative where the workers are building up this material production company called BC Materials. So I will touch a little bit on everything in a short time today. But of course, in the end, we're just one group of people. Oh, okay, I didn't see that one. And so just very quickly to, talk a little bit about what kind of conversations are going on within our group of people working on these topics. I tried to summarize it in one sentence with different lines. It has always been a matter of common sense to design for the long term in scarcity. Circularity is not a miracle. We talk a lot about what is it, circularity, this new buzzword, should we go for it or not, how can we be critical and so on. So it has always been, for us, that's something that lives a lot. What we're doing is nothing new. We're not inventing. We're not necessarily innovating, because, you know, innovation is kind of this byproduct of technology talk, let's say. This is a picture of the basement of the Hagia Sophia. The first stone where the basement pillars are put on is actually recuperated from a Roman temple. And so, like, reusing things is actually not new. Circular economy is actually not new. We just kind of forgot it for a certain while. A matter of common sense. I really love this example. This is what we call how to call it in English, a wanderer's barn. It's an official term in typology discussed in heritage sector in Belgium and Netherlands. And in fact, it's a barn that was with numbered oak beams and with earth and straw as an infill. And so this barn traveled every few years where the farmer needed his infrastructure close to his land, where the barn was demounted, earth thrown on the ground, straw thrown on the ground, beams demounted, taken to the next place and remounted, and again earth from that new place as an infill. Super common sense, you know, there's nothing high-tech about it, it's just plain common sense is what we should do, you know. To design for the long term, very quickly, you know, like I think one of the best examples, understandable by everybody, how we are actually unbelievably not taking time into consideration is, for example, the building cost. We only calculate the building cost at the start of a project, but in fact, if we look at it over time, if we just look at the economy, and then you can extend to ecology and so on, you see that the actual costs of a building are much more in its life cycle than the initial costs. So if we invest more in the beginning, in fact, economically and ecologically, we can also have more gains. If we do better things in the beginning, we can have more value later on in the life cycle of a building. So we have to design for the long term. Scarcity, I think, I will not explain it a lot. We live in times of scarcity. This is a graph from the Flemish government taking global data of resources until when we have certain types of resources. It's limited. And then also circularity is not a miracle, because how we are focusing now on circularity, it's kind of narrowing it down to kind of recycling, going to reusing. But in fact, this might not solve our problems. There's things where we always need new materials for. And so if we recycle everything that we output as a waste, we only solve 27% of our material use problems. So circular economy is, if we focus too narrow, it's not going to solve everything. This is, by the way, a very nice website, Low Tech Magazine, a super inspiring website with lots of interesting articles where we took this information from. And so what we think is like we need to transition. We need to have systematic kind of change in doing things. That's why, we need to work on all fronts a little bit at the same time. And for us, what we then do, we try to work very broad in our projects also to try and touch on all processes, not only design, not only construction, but also like knowledge, education, and so on. And so for us, prototype, I heard it also in the first lecture, making things together is a kind of a crossroad where a lot of these topics can come together. And so in fact, that's what we kind of want to do or want to elaborate or want to develop. It's kind of an architecture as a prototype, you know, it's a process that never stops. A building, more and more we know that it's never finished and it has an end, and then it keeps on living as certain types of wastes. And so we have to take this into account and really focus on the process of construction. Our first experience for this was actually coming straight from school. We had the privilege to be able to work in Burundi. And so here, low budget, low tech projects, earth from the side, digging out a mountain, using it to make compressed air blocks. For us was a first experience to do architecture. Like we didn't have any experiences in offices with normal procedures of architectural design and then construction and so on. This was kind of a messy but very inspiring process. Where different people were brought together. For example, Salvatore here in the middle with lots of construction knowledge, never worked with earth. Then us with no experience whatsoever, but very, very motivated. And you know, like learning together how to make this little building, there on site, and design changing as we go because stuff doesn't work, other stuff does, discoveries and so on. And so this kind of architecture as prototyping, in fact, we learned it there in this year and a half that we lived there. And it has never left us since. So I can honestly say that everything that we do now, 10, 15 years later, we have learned in this setting with these people, and this, amongst others, this construction process. I want to show one architectural project to just show you how it goes today. Like when we take on this kind of project, this is the south of France where we work together with Assemble, a London studio, and Atelier Luma, a design research center for which the headquarters, the infrastructure was needed. And so it shows already that the client, Atelier Luma, was actually also part of the design team with their knowledge, and so it's kind of this mixing up of responsibilities and roles in order to prototype together and do new things. Actually, it was a renovation of a train infrastructure, train repair infrastructure that now becomes something else in the Parc des Ateliers in Arles in France. And so the renovation started, in fact, from a big research, lots of visits, lots of talks with people who deal with certain types of materials. For example, I will see if this works. No, okay. So, for example, here we see on the left above picture, it's the quarry of Saragan. It's a limestone quarry where they have accumulated cutting waste since decades. And the quarry is open since 150 years. And so there's actually, they fill up the hallways that they create again with this stone dust. So it's in fact a very high quality, very special kind of sand, a stone quarry waste that we used a lot in materials in this project. Under that you see the Orange River. It's in fact a waste from sand washing, another type of sand that they washed in order to use it for concrete. And so they have this river that dries up and then creates these blocks of clay that for us were also a starting point to develop certain materials from. Here on the bottom left, we have a rice straw in the region of the Camargue around Arles. There's a rice cultivation with problems of agri-waste handling. Currently, today, the waste of the rice straw cultivation is burnt every year by the farmers. And so, in fact, this is a high-quality straw that you can also use for construction. on the right above, we see sunflower harvesting. And so the sunflower was the first time for us that we worked with it. It's a super interesting material where we have the sunflower head, which becomes a kind of polystyrene, but bio-based, bio-sourced version when you shred it. And then the stem, which creates for very strong fibers. And then here at the right bottom, we see demolished buildings from around Arles. Lots of nature stone buildings that are demolished. So actually what you get is high quality gravel, which is legally considered as a waste from the demolition of buildings, but actually, which is a very strong gravel to use in construction. Just to show you a little bit what we have been mapping, there's much more, but I try to make a selection. And then from the start, architecture is prototyping. It starts model materials next to each other. It starts at the same time, and the one informs the other one and influences each other's path, let's say. This is the warehouse plan. We have 3 parts. The long one is more the biosourced, let's say, focus. And the square one here is more the geosourced focus. And then the empty one, actually we left it like that. It's kind of a multifunctional hall. Here we see the model from the top. And so there it starts, the prototyping. Here, wood that was sourced from the Jura forest, where we went visiting the forest managers. Here painted with an algae paint. Algae also grows in the Camargue region. And then in the end becomes the structure of this divider that then defines the space with different kinds of workshops under it. The rice straw was used to, of course, use the bales of rice straw. Lots of volume that was used as an insulation on the inside of the warehouse, but also in a hot press functionality, we developed rice straw panels that were used as a finishing of the inside until like 1.5 meters high. The waste from the stone dust quarry was used as one of the main ingredients to make a rammed earth mix. So you see it's a white rammed earth mix. It's quite special for rammed earth to be so white, but it comes mainly from the debris from the quarry, and the white limestone quarry, and which resulted in a very beautiful white rammed earth. We didn't search for white, even though we're architects, but we were very happy to, to discover the white rammed earth, let's say. So on the left you have the stone dust quarry, and then some other resources, the crushed buildings, the clay that was dried up from the sand washing, and so on. And of course, all of these materials, this is a big project of around 7-8 million euros construction budget. So there was a controlling office there who never works with these kind of materials. So a lot of discussion, a lot of learning together, how to test what are the protocols, what do we demand of these materials in order to be used structurally and in terms of insulation and in terms of acoustical absorption into this project. And so a lot of testing was done in order to make these material prototypes into real building materials in the span of a specific project. Here we see the rammed earth walls being constructed during the construction site. There was also a bit of a focus on reuse. These are the tiles on top of the roof that were actually gathered. They were not good anymore to reuse as roof tiles. They were too soft, have gotten too soft. And so we used them as pieces, kind of aesthetical gravel inserts into the outside lime plaster, and also as cut longitudinally as kind of aesthetical writings of tiles into the lime terrazzo floor. Algae plasters was a very new discovery for us, and we're going further in it as we speak. after this project even. So the algae has a very special. These were like algae residues, so it was like food production of algae creates also kind of algae residues which are not pure enough for food, but for construction it's always like this. For construction it's still okay. It's the same with straw and everything. So the construction materials are very complementary to food materials. And so in fact, we did different algae plasters, and the binding qualities with specific types of sand, not with all sands, are really amazing. We create very high quality plasters in terms of strength, in between clay plasters and lime plasters. Also discovery for us. Clay plasters made from the washed clay from the sand quarry, and also acoustical plasters on the right. You don't maybe see it very well, but they're projected and left rough, and the polystyrene, biosourced polystyrene from the sunflower head, in fact creates a kind of porous and slightly elastic wall surface that is super good for acoustical absorption. So the sunflowers are used for the acoustical plaster. And so, you can imagine all these materials, who is going to execute them, where are we going to test them, are they even allowed, the conversations to be had with the controlling office, with the engineers, the stability engineers, and so on. A lot of discussion, a lot of network, a lot of discussion, dialogue, a lot of talking, trying together, and these prototypes on the site from the beginning gets everybody in a different mindset, let's say. Everybody, contractors, even us architects, to discover materials. And so these moments of prototyping were very important. We also opened them up sometimes to people from Arle or further students who are interested and so on in different types of workshops. In order to learn together, because that's the only way how we will move our big boat and the systemic change towards more ecological ways of building. It's to work on it together and to discover and learn together in prototyping phases. And this is more or less the end result a few days before the opening. You still see the tables a bit on the side. A very beautiful light. The colors of the region, there's no pigments, it's just what we worked with. We used, what we found and what we discovered, we used. And it's very beautiful light, and in the end, very special environment. And so, doing all of these types of projects makes us also think this is a project with a lot of budget, but not everybody has this kind of budgets to invest so heavily in prototyping. And so that was for us the biggest reason to also start a company like BC Materials, to really not only have our engagement linked to certain architectural projects that can pay for it, let's say, and that have the right context to go for it, but also to engage in a more broad way with our society in terms of what materials should we use. That was the starting point of BC Materials. And so we kind of took the same logic, but on a bigger scale, and we looked at, okay, what actually is happening in Belgium today with earth. And so if we look at excavation earths, so excavation from urban construction sites, and you dig out an underground parking garage, for example. In fact, only in Belgium, so you can imagine for Europe, only in Belgium, this generates around 37 million tons of excavated earth per year. So it's enormous quantity that is being excavated. And it's very linear, around 40% is reused in landscaping works, such as road construction, and 60% is thrown away in landfills, in quarries, and so on. Sometimes we go to Germany, to Netherlands, to France, because there's no place to do that in Belgium, and the quantities are just too big. And so it comes with all this kind of problems of transport, CO2 emissions, and road congestion, and things like that. And so what we then said with BC Materials is, okay, let's act on this supply chain of earth, it's geological earth, it's non-polluted, it's non-disturbed, so it's the real geological layers, which is legally considered as waste, but it shouldn't be. This is just like we have all kinds of little quarries that every construction site actually is. And so we want to use those resources to make building materials. And so we do that in two places on the supply chain. One is we go to the place of extraction, the construction site where they're digging out, in order to transform those materials. That's mobile machinery, it's small scale. For some projects it works. Or the other one is we kind of attach ourselves to the temporary storage centers where earths are gathered before they are being disposed of. And so that's our stock, our stock production, let's say. Yeah. And so then, like for us, why is this so obvious? Earth construction is for us like common sense. It has always been, and also very circular in the sense that you use something that is considered as a waste, but you also use a product that actually does never lose its qualities. We have done it already multiple times. You can scrape a clay plaster from the wall, re-wet it, and apply it somewhere else. So you're actually working with the soft crust of our planet and using this to build our infrastructure, which in geological time, in the long run, the long perspective of things, is in fact not a long time used, maybe 50 or 100 years. And then you can just give it back to the earth, it's just earth. And so, yeah, very quickly, so this is a section of Brussels where we source from the construction sites our earth. We see the yellow parts, which is High Brussels, which historically has been a mortar sand used for making mortars, but today is legally a waste. Or the Valley of Brussels, where we find more clay materials. This is a construction site with sand on the Brussels hills, let's say. This is a construction site in the valley where we have high quality clay. And then also the same thing, we use gravels as our coarse materials in our products. And so we developed a range, it goes from plasters, fine plasters, paints, accessories, ram dirt, and in the end also compressed earth blocks and molded earth blocks that we now sell on the market. And we do that not only us, BC Materials, but we use the partnerships with production capacity, which is available in the Belgian society, a production capacity that is not used 100%, and that we say, okay, let's just do an industrial co-working, let's use your machinery, and we insert earth, and we get quality products from it. I will skip this. Just to give you an example, you already see a bit the different scale. For example, these are compressed earth blocks, but actually made in concrete block technology. And so we are here at an output of around 300, 400 tons per day, while before, if we used our little machine, compressed earth block machine, we were at an output of around 8 tons per day. And so like the scaling up is very important. You need to work together in order to lower the price. And so here you see the guy with the glasses, that's the owner of the factory. The two other guys on the left are his two sons. And so, in fact, these are people everybody is talkable to. You can always collaborate. You can always explain people, develop stuff together, prototype together, in order to use everybody's knowledge to arrive at good things, good solutions. And so here, this compressed air block is really like a very, very high quality, very good product. It became cheaper because of the upscaling, of course. And then one last thing, BC Materials always also wants to innovate. It never stops. We always need to think further about what materials can we replace, from what fossil fuels intensive materials on the market currently can we replace. And so, for example, something really promising for us is this cement screed replacer. It's actually an earth screed poured with the normal machinery again that the concrete guys know really well how to work with it. It's beautiful machinery. They just put the wrong stuff inside, and this you can also put earth inside. And these people, they learn in the beginning, it's like, wow, what is this? you know, this will not work. I'm not putting this in my machine, no way. But then you talk and you try the first little bits without risk, and then they say, it passes really nice in the pump. Okay, let's go for it. So this is the impact that we need to have. You know, this is the prototyping that we need to do together. And so this results in a product range which is called Leem, that you can see on the website, leem.works. So I invite you, you can check it a little bit yourself. And so, yeah, this is a bit the story of how we started prototyping without knowing a lot of things, without having a proper architectural experience somewhere, and how we took this first experience and like developed it into what we think might be one puzzle of the solution to make the systemic shift in our sector. Thank you very much.
Thank you. Please stay with us. Stay with us, Ken. Stay on the stage, and please, all the other speakers, come up here, take a seat. In the meantime, if there is any question to the last speakers, take a microphone.
This is a question to Petra Gruber. Thanks a lot for your presentation. You showed a lot of different ideas how to work with this fungi. What I didn't see is how do you choose which kind of fungi do you use? Is there do you just let it grow what comes, or do you insert a certain species to the waste you're working with? And the other question is, I imagine this fungi foam or whatever is a result very soft, and how do you use this? Because I mean, most of the building materials I know are quite hard or rigid, and I find it very interesting to have this idea of soft materials to work with. Thank you.
Thank you for the questions. We actually add the fungus to the mixture. So the process works in this way that you have to sterilize the substrate first, and then you add the species that you want to work with. So it's something that you purposefully generate, and it's kind of pre-grown on mostly corn. So what you get from the growers is a specific species mixed with a spawn. So it's kind of a pre-grown fungus that you can add to the substrate. And then there's questions on how do you mix that well. We had big issues with long fibrous materials. For example, flax would be great for building, but then it's very hard to mix it properly. So there were all sorts of challenges in this processing. And then I forgot to say, I brought some samples. Those are very dense. They were compression tested. So it's not soft at all once it's dried. It's like I would say almost like Heraclite or something that you conventionally know from insulation. It has really good insulation properties. It's very fire resistant. So be careful, it's a little dusty. So if you open the bag, it's a bit, it's not dangerous at all. So the fungus species that we use are not dangerous. So no, nothing to worry about.
So if there are no immediate questions, we would like to go to the next step, the panel discussion, and it will be moderated by Christoph Kaltenbrunner. Christoph has been head of the Department of Design, Architecture and Environment at the Institute of Art Sciences and Art Education at the Angewandte since 2014. He studied mechanical engineering, architecture and industrial design. He received several scholarships for study visits to Japan, England and the USA, and was a founding member of the architecture studio Propeller Z in Vienna. The The studio's work has won numerous awards and has been widely published and exhibited. And now Christoph will lead the discussion. And I'm very much looking forward to a vivid exchange of ideas between all these participants. Thank you.
Thank you, Karin. Good afternoon or good evening. I had an idea how to try to manage this round here, but there was this one wonderful quote I want to start. But at first, I want to divide this discussion in one panel discussion and then the second half to questions from the audience. So there was this wonderful quote, Petra, you mentioned from Rick Huskes. I hope I was right, yeah. He said, if the bone is the answer, then what is the question? And I like this really much. And I tried to think about if I change the bone of materials, what it does mean. Yeah? If the material is the answer, then what is the question? And I want to give this question to you forth. Maybe you can give me some idea or answer of this quote, what the material can be, and what the idea must be to find this question. Petra, please.
Okay. Good question. I don't know. I always was. I mean, what struck me about the other presentation was also the reference to tradition, and also the occurrence of ephemeral structures or transportable structures or not so permanent systems. So my sense is that having grown up in Austria, where the land is really important and people stay at a spot for a very long time, so the building tradition here is a very massive one and is thought of a very permanent one. So we think about materials as something that is good when it's lasting, right? And my current understanding of also places and also property and mass is something that could also be very different. I don't know if it needs to be mediated by technology, but I think our position towards space and houses and places where we can stay could also be more flexible and more immaterial. And in this sense, materials also there to mediate, right? But if there's other ways to mediate, maybe we wouldn't need them at all. Maybe a curtain of warm air would be enough to shelter us. So I think thinking about that, creates another dimension of potential space and potential action and how we treat materials and design. And on the other hand, there's always this experiential materiality that I'm still very fond of, right? So I'm coming from also a craftsmanship background, so touching leather or smelling leather is something that I grew up in a saddler workshop. So this is something that's so ingrained in myself. So I couldn't also imagine to detach completely from this sensing quality. So it's kind of those two things, like changing the attitude towards space and having this kind of very fixed locations, and on the other hand, this experiential quality of materiality that strikes me. Did I answer your question?
Yes, but you give me a further idea to announce, okay. Ken, about, as you mentioned, the solid buildings we try to build in Austria, and you were talking about the barn. You can dismantle and change from place to place like a cabin. But coming back to this quote, what's your idea about this quote and moving with a building in the country?
Yeah, so when I hear this quote being applied to materials, I think Petra already touched a little bit on it. For me, materials have agency. Of course, they're not subjects in the sense, but they have agency in the sense that they can pull us in, and it's something that we always notice in our workshops, in our prototyping sessions during the design. Like we ask that everybody joins, like engineers, the guys from the controlling office who normally only read norms and things like that. And there's something that happens, and I think it probably has to do with the disconnect that we more and more feel, or that we more and more experience with our environment. We're working more and more on computers. We have started to produce things in more and more efficient and subdivided ways, and there's a loss of some kind of connection, and the magic happens, the agency happens when people start to touch this material again. And it's also, I had to also think about what Petra was showing. In fact, it's again the connection with the biological model, not a technological model. And for me, that's if material is the answer, then what's the question? For me, that would be it. The material agency. It could be something that pulls us in. Even though, if material is the answer, then what's the question? Normally, people will say, which is also true. We have worked so much on the operational carbon emissions of buildings, but not yet on the material embodied carbon emissions of buildings, and so that's also a reason why we need to focus on it, and that's what is being said in the scientific, sustainability environments. But for me, what is difficult to discuss, because it's something emotional, it's something tactile, it's something about impact on our behavior, on our mind. That is, what is it about materials? It's the fact that they pull us in and they show us where everything comes from, what we can do with them, what happens with them when they're waste. Like if we engage with materials, we suddenly feel the whole cycle. Yeah, and it's not just anymore in the mind, so in the brain, so to speak. It's the experience.
Thank you. And now I change a little bit this quote and ask Thomas, because I was really astonished that you're using wooden nails in structures. I thought it's not allowed to do this, and so I changed the quote in, if the part is the answer, what is the question?
If nails in wood are not allowed, it maybe there are norms that would forbid this, but I don't think in this kind of sense. It's more like Ken told, it's the experience we need for the materials and the experiences of the ancient, and that's the way we can look on things. Because these experiences, maybe we lost a lot of them, but now we have to renew this action and look what's the properties of the materials. So that would be maybe the answer, that we have to really start the research once again, because we are a new generation, I think. We are not the youngest, but we are a new generation, and material and the properties and the characters of the material we need to know, and then we will find the right use. And I think the materials which come from ground, from nature, from in biological terms, they have the advantage that they can go back to nature without any waste. And that's why it's interesting to work with earth. That's interesting to work with wood, but with a lot of stuff, with natural stone, but also this kind, what Petra is searching. I think it's fantastic. But there, for me, I'm a little bit afraid because I have no idea about what happens with spores and all these things in our kind of using materials. Spores are a dangerous thing. In wooden structure, we have problems with mushrooms. So I think I'm very interested in this, but for me, the experience doesn't exist at the moment. I believe in a further future. I heard about these materials and about this ephemeric character and all these things. I'm interested in the future of this. For the other kind of properties and materials and thinking, what's the answer? I think, each material fits to one thing best and to other things even too. So you don't, it's not a singular, how do you call this, a singular look on things. It's always the combination. And that's why wooden nails function that good, because the hole is bigger, the stanchions are not directly on the cell itself in the wood. It's a broader approach. So 20 screws are the same as 2 nails. You can reduce it like this, and testings would show this. I believe in this.
And even to dismantle this building is much easier with the wooden nails as instead of screws.
You can do it by saws or something like this. You don't destroy the things. Even you can take part up. You can dismantle by the single parts, and that's very interesting. The objects I showed, these old houses, were transferred 1-2 times in lifetime. They were dismantled. They put it 1 tram in and made bigger rooms because the people get higher. Because of health and all these things, they got higher. So the rooms were too small. These objects I showed you, they dismantled it and they did 1 tram in and put it together. So it was possible with this kind of construction, with this wooden nail, they fit it together. So they could part it or depart it and put it together once. That's very interesting. Even that's why it's, I think a future. It's not looking back. I think it's interesting for the future of building.
Thank you, Thomas. In your lecture, you have shown a lot of different way to build with wood, with sheet wood, with logs, and even different forms, how to bring this together. And so I changed the quote in, if the form is the answer, that what is the question? Looking a lot of the Faltwerk, it's called in German. I don't know the proper English word for that. Folder structures, please.
Well, I would like to go back to the discussion we just had before. First, I think there are lots of connections between those presentations one can already feel, and I was just thinking about, you know, those old chalets from the 16th century. When you dismantle them today, the timber which is used became always mineral during the age, like stone. It's very interesting to see that. And then there's this utopia about, you know, that when we cut a tree, then it's fresh, and then we dry it, and then we use it as build material. But we haven't the connection to full cycle yet. And when you speak about living building materials, there could be an utopia that you would say that you start actually planting those trees, that they become a construction, and that, so there's a transition between life and death, somehow to be taking up about a business model we don't know yet. And I believe lots of those questions we have questions the business model. I think, and you showed very clearly, and we and I think it should be a radical change even. So there's something about logistics which has to be replaced to this cycle, let's say, philosophy in a holistic manner, which is much larger than economy or construction economy. So that's a bit how I see it. And personally, I'm more interested in space than in form, just to let you know. But it's, I mean, I see connections with what we have really also been seen in Thomas' presentation, where when we have lots of small connections, it's actually biomimetics, because we have a lot of, we don't have stress peaks in terms of resistance. We have sort of distribution of the stresses, which we don't have in traditional carpentry, because there we have knots, and then we have prismatic sections, and we have to dimension the whole structure in reference to the dimensions of the knot. And when you use surfacic elements, as we do in nature, in this case we can distribute those forces. For example, in folded structures, we distribute the forces along those edges, and we don't have those stress peaks. So we work with the materials in a low way.
Thank you. Coming, of course, it's space, but space are forms in combined. But what I want to talk about is more to focus on the building side, because this was we always talking about or in our academic system, but on the building side, many things changing quickly, because as I remember when I studied architecture, Hans Buchhammer always mentioned a word about the water, about leaks in some seals, because the timber, or even steel, will be rotten or rusty, and the material gets weak and is a danger. How can you control in the idea of sustainability? How do you doing the detailing on the scratch in the office that the details are working on the building site too? How you can control this, and which kind of material are you using? Because in this case, most times petrochemical materials coming in on the site. Ken, please.
Yeah. I think it's a lot about building culture, first of all. So I wouldn't say it's decided on the design table, on the paper of the architects, even though you have some solutions. You first build a roof, and then under it you fill up. That could be a solution. But I think it's more of a building culture. I have to think about a construction site that we're now doing. It's molded earth blocks, non-stabilized, load-bearing. So when it rains on them, it becomes earth again, and they're not water resistant. And so, yeah, we just were with the contractor on site, showing him how it disintegrates when you put it in water. It's a communication thing. So he needs to protect it, and he needs to understand where the damage is. It's only from the wind-driven rain side, like the other sides are okay. And so once you do this together, it can be something that can be worked with. A second thing that I think about is seasonal construction. Just like how we harvest seasonally, it could also make sense with some materials to construct seasonally based on the characteristics and the properties of the materials, which is also a way how to manage certain conditions, maybe not only rain, but also humidity, like in the air, frost, and things like that. So I think to dive more, to understand more the specific material that you're using, and to organize a building site more towards the logic of this material that is part of an ecosystem, I think that's for me the most obvious path to go towards a building site that can use these softer materials.
Thank you. Thomas, you have shown this one image when this beam, the crane end was showing to us, and this is always a big problem of water and of fungus too. When you're working with old buildings and old beams, how to manage that this will be proper done, that it doesn't rot on this crane end, for example?
Oh, I am testing it by knocking on it, and you hear by the sound of the wood if it's good or not. It's a damp sound if it's bad, so you know it has had a lot of humidity in it or insects. So you have to change. You can't rescue this. So you can decide by knocking on it if some wood is good or not, and so you have to decide or ask somebody who has the same opinion. So I always talk with the craftsmen in this manner, and we decide in common what we will do with such things. The other discussion about the leaks, the roof in our region is one of the important things. I think it has to be more or less good, but the old structures show that if there is a lot of space and wind going through, it doesn't matter if there is 1 leak, 2 leaks, 3 leaks. If you repair it 2-3 years, you can look what happens. That's why I did a roof without a barrier. So I see the roof looking up, and when I see a leak, I can repair it. So that's our problem. And nowadays we all we make a lot of sheets and different layers. Yeah, we do a lot of layers. At the end, we don't know what's inside. Even we don't what many layers and what are the materials in this layer. So if we do a lot of layers, we complex the problem itself. So we have to come to easy construction types and to construction with only 2, 3, 4 layers at maximum. If we are talking about the roof and the walls. The other thing, I did some buildings where we had leaks in the outer wall, in the cellar, and I could convince the people to accept this. We can, I forgot to show, I have one example actually where the water runs through. We did really open flooring where it can go below and travel through the fundaments of the housing. It doesn't matter. Even it's for the humidity of the room and the atmosphere, it's better. In winter, it gives humidity because normally it's too dry in winter in the rooms because of heating and dry outside air. And there it's a big advantage if this water goes through. In the summer, it helps for cooling. It's an easy way of cooling, and I could convince that the owner or the woman of the owner that it's good, and she has accepted it, and yeah, now it lives. You see, if there is a lot of rain, 2-3 weeks, there goes a little, river, not river, but you can see it. I can show you photos. It functions. So leaks are not the problem.
If they're well done.
If you know, you have to manage.
Yeah.
Water you have to manage. It's in new facades, in new roofing. It's always the same theme. You have to manage the water. And if you manage it good, that's why natural stone walls are a lot better than concrete stone walls because of the capillarity of the pores and all these things. In a natural stone wall, you don't have this problem because the water can go down If you use plaster, it comes up. So you have to really have a look what happens with the materials, with all the things, and to manage the water good is the most important thing.
Thank you, Thomas. Petra, Thomas mentioned that the fungus are the enemy of wood constructions too. How do you can convince us that the fungus are much better than what do you think about it?
Well, we use the fungus in this particular example to perform something for us. So the fungus on this micro level, solidifies this aggregate. It creates like a network that binds those particles. And the fact that it's alive doesn't harm us until the fungus is toxic and produces spores. Sometimes the spores itself, due to their size, can harm our health, even if the species itself is non-toxic. But if you can prevent the sprouting, you don't have an issue. And if you kill the fungus so that it's just the network that remains without fruiting bodies, you also don't have any problems. So either you can work with those like dead materials then in the end. So it would be like you use the fungus to produce the material, but then you kill it off by baking or by drying, and just use the material, and then you don't run into problems with spreading spores or spreading the fungus to the rest of the building. Or you could use the living one in an outdoor environment where it doesn't hurt anyone. So if you have enough ventilation, or if people are not affected directly, then you would not run into trouble. And the presence of water is also one of the main issues. So anything that you have in biomaterials is probably also responding to water, and is water solvable. So water is always a big topic. Managing water is always very, very important, and especially in our climate, when you have water in the material and you have freeze-thaw cycles, the material is just prone to deteriorating very, very fast. So our climate is also not helping with this additional complication. But I think that managing humidity is something that is also not really activated as much as it could be. So for example, especially clay is buffering humidity to an incredible extent. And I think that many like room climates could profit from the presence of clay walls just to buffer the humidity that is existing in the space. And in spite of us knowing this, we are not testing enough, and we are not playing around with this effect enough, in my opinion. I think we could elaborate that way more and experiment way more with this.
Thank you. There are very good example by Mr. Rauch in Vorarlberg, like the clinic in Feldkirch, I guess. This is wall, and this is about 30 years old, and it's changed a lot the climate in this big hall. So it's maybe we can put this more in our teaching here too. If your buildings or your discussion at the university in Lausanne, how you discuss about fungi and waters in buildings, in structures, how maybe to, as Petra says, maybe they are not enemies, maybe they're friends in an environment.
We have no experience now with fungi at the university, so we haven't really. It's more like it is true that humidity is the enemy somehow of certain. So we teach the students to design a wooden structure so that that structure is not exposed to humidity, so that it stays for a longer time. And it is true that we have a clear separation between structure and waterproof. And I'm speculating that we could actually abolish that border. It's also two craftsmen separated, and I was thinking, I mean, when you take the hat of the king of Rwanda, which is actually the same culture than Burundi, it's a shell structure made out of bamboo of different sizes, and then it's a trough roof on top of it. So it looks like a scale jump between the structure and the waterproof, and the structure stays, and the waterproof can be renovated or maintained. And it's also something related to very natural aspects. So I think our building techniques needs to be questions much deeper. And we said this already, that we want to go to more simple construction, more simple detail. I think that's something which should be questioned as well.
But just wanted to add on this. I hear it coming back, like needs to be maintained and needs to be worked with, needs to be taken care of, building taken care of. Yeah, just I think a systemic change is not only material change; it's also the habitual, the cultural change about how we. Now we expect a building that, you know, when we build it, that we don't have to look at it for 20 years. You know, like it needs to be like perfectly performing, and we don't do anything about it for 20 years. It's like a firm, strong object. But in fact, maybe that's not, you know, maybe that's too much a technological model of how we experience our surroundings. Maybe, yeah, like I think it's not only about the materials; it's also about how we treat the things that are made with materials around us, and that's even a more difficult change than the material changes itself, maybe, because how do you change that?
Thomas? Yeah, you are fully right, Ken. And that's what we found out. All the damages of the ancient buildings are damages of people, of wrong materials, P4C, flooring, and all this, and not looking for the water handle around the building. So normally we tell all 5 years there is a maintenance cycle. You have to look about the surrounding of the fundaments. You have to look about the wooden plates, all these things. You have to look for the roof. And we lost this kind of looking to the houses. And so we claim that we have problems, but this we can change, or we have to do a shift to get obvious what we have to do with our buildings. And only in this manner we can manage other materials, real natural materials.
You said something what I really liked, or the thinking. You said, or other way, not when the building is when the construction is done and the building is finished and the key is going to the client, it's not the end of the building. When for my own practice, we always thought about how the building looked like in 20 years, and this is the span, and this patina should be placed on the building, and this is changing a lot of the behavior of maintainers or the behavior of a building too. And not only the white flush building, bring it to the client with the key. Now I want to bring the questions to the audience, please. If there's some questions from the audience. Peter? Anton, sorry, Anton.
Yeah, Anton Falkas, Institute of Architecture here at the university. Yeah, thanks for your presentations. Very interesting conversation. I think I just want to continue what was on the panel in the last moment is, and I think Peter was touching on this kind of issue. What do we need? How we are going to materialize our ideas? This kind of permanence, what we apply to a building. So is it enough to have a kind of a bubble of warm air around us? So I think what I was kind of missing in the conversation about circularity is also the idea of impermanence of materiality. So do we have to keep a building for 100 years. So this is what is our approach here in the Western kind of idea and our Western world. So I remember when I was a research fellow at Tokyo University, so the idea was that you have this kind of Shikinen Sengu, this kind of rebuilding of Ise shrines, for example, which turned out that they are going to replace every single building every 20 years. And so the only thing which is permanent is the idea of a building, but not its materiality. So I think is this kind of impermanence, do we have to keep this as the most important strategy? Because we are going to create wealth, which we can kind of sell and deal with on the stock exchange, or do we do buildings for something else? Okay, maybe somebody could kind of comment on this.
So I feel that these ideas of permanence or not permanence are very deeply ingrained in specific cultures. So Ken and I actually met in Ethiopia, and the Afar people there are nomadic pastoralists, and the households that they own fit on one camel. So that's the house, that's a few pots, that's the bed. It's an actual really nice bed. It's made out of a mat and, like wooden pieces as foundations. So they have apparently everything that you would think you would need in such a climate for this kind of life. I mean, it's a very, very simple life for sure, but the basic things fit actually packed up on one of those animals. And it's amazing to see those people just using the space in a completely different manner. So they go from a defined spot to another defined spot to feed their animals, and they have their rhythms and their roots, so they also cover a lot of space and use a lot of space, but in a completely different way. And all those rhythms for sure are totally disrupted by war and climate change as of now, has been for years. So this is something that we are on the verge of completely losing. But it's just one example of a very different approach to how you treat space and how you treat belongings and what you actually use in your life. What is it that supports your activities? And I think we all know, as we're sitting here, that we have way more than we need. We are busy keeping our stuff together. We are using a lot of our lifetime just organizing stuff that we don't need. It's quite absurd if we think about it in this way. And so I think that less is more. And I think we could also rethink some of our cultural connotations of ownership, of how we use space, of what we actually need, and treat those design tasks in another way by also initiating this rethinking of how we want to live in other people. And then the design space suddenly extends into a social or even political domain. And this is also something that I think we need to be. And I think what Ken showed, like this rethinking of technology and doing things differently, is such a great start of that, right? So having those traditional value chains and, commodities, and then suddenly bringing those materials in as another value that was not seen, this is already a pretty radical shift that changes those networks. I really like that about your presentation, because I think it goes into this direction that we have to move forward to.
Thank you, Petra. Please.
Thank you. My name is Rikke, and I'm from Denmark, participating in this tomorrow. I work as a landscape architect and urban planner. So I just, thank you all for very, very inspiring presentations and new knowledge for me, and sure for everybody. But seen from a landscape architect point of view, landscape is the background of everything man-made. And if we're losing that knowledge, we are losing ourselves. And in my opinion, or in my knowledge, building are only details in a bigger picture. So I was just wondering, perhaps you can answer that, if we can learn to maintain buildings like gardens, because to maintain gardens is something that we know that we need to do in certain periods of time every week, and during winter it's not so often. But it's a huge cultural, perhaps not a revolution, but an evolution to start thinking of our buildings as landscapes. Is that possible?
Thank you very much for your remark, your idea, because it gives me a point of view that I didn't think of. When people ask me personally, like, why am I into earth and other like soft materials? In fact, like, besides the talk that I give, very personally, it's a bit difficult to explain, but I think it's just amazing how from the soft part of the earth you can build something temporary. and afterwards it just, when we're not there, I mean, we'll not be here forever. Like, when we're not there, it can just go back to the soft crust of the earth. And I think it's a personal thing, it's an intuition that I have. I think it feels so right and so beautiful. And that links a little bit with your idea of gardening. A garden is also something, when you are there and existing on the planet, it's your interaction with nature, it's your garden, and then afterwards it's back to the ecosystem. So yeah, I really like that idea, the temporariness of actually building is nothing more than landscaping, like the soft crust of the earth, giving it a certain form for a certain time, and then afterwards it should be able to go back to geological forming actually. And so I think, and it's a bit linked with what notions of time that we live by. Time is like very, we time everything every day. We time our tasks, we time our day, we time our weeks, we time our year, we time our life, we plan our life. But in fact, there's other kinds of times that I think is good to reconnect with. And that's why I really love talking with geologists, because geologists, they really show us that there's also other times, that gives us perspective of how we are here. We are here only very temporarily and very short, so we shouldn't look for permanence. We shouldn't look for hard buildings that seem to stay forever, which is totally not true. It's this notion of building as indeed like landscaping that also really is very much talking to me. But it's difficult to explain that to a broader society. So I stick with the things that we're talking about before, but in fact it's my personal intuition that this is really important. Yeah.
We have another question here, sorry.
Thank you. Thank you for your wonderful presentations. I have a question that starts with Ken's proposition for systemic change, and maybe can be expanded to everyone if you wish. My background is a historian, architectural historian, and I was there's one detail in your talk that really struck me, which was like, we weren't looking for white, but it happened to be white rammed earth because of the limestone that was there. And I think and there's something incredibly heroic there in my I think, in the sense that recalled in my mind like Adolf Loos searching for the specific marble for the Goldman Sachs building, or Mies van der Rohe looking for the marble panel for the Tugendhat house, and it has to be that marble, and it has to be cut, and it has to be book matched. And And I think there's something incredibly, like also when you put the pieces of tile to create this pattern, which then you start describing as a writing, you know, of all these excavations in a way. And there's another reference that also comes to my mind when you show the Earth, the geology, and Georges Cuvier, who we know is a natural scientist and a biologist of the 19th century, actually he was also looking into geology of Earth, and this is when they discovered the city in France, Caen, limestone, and they discovered there was actually a tropical swamp underneath it, which is why there's that limestone, so on and so forth. So there are all these historical parallels that I can draw. But going back to the whiteness of the rammed earth, of that specific rammed earth, and the tiles, the writing of the tiles, I guess the question is, in this systemic change you're proposing, what's the role of aesthetics? And that can be extended, actually, if anyone else wants to take that.
That's a really nice thought that you shared. Thanks. I think I will not make the answer long. I think the aesthetics in our office is that we don't do a lot of aesthetics, but we think it's super important. Beauty is super important, but we don't do beauty. You know, we don't control beauty. Beauty comes through discoveries, and we just are wondered, and we are being led by aesthetics, but we don't create aesthetics, something like this. So I think your point is very true. But
maybe an answer on this. We can talk intellectually about these things. The problem sometimes is the client itself and the client's expectation of a representation. A building for a client always is representation, and that's why he wants it to dure. He don't want something that go away in a few years. So he wants to show that it's a building of substance, and even the representation part and this white thing, I think it is really a well aesthetic things, and the white marble is only a thing that the client wants to show he has money. And we can talk about here new materials, but we have to shift the expectations even, because without the right clients we can't do anything.
Thank you.
Thank you. I just wanted to ask you, because when I came, my name is Ramesh Biswas, I'm a professor here. When I first came to Austria about 100 years ago, one of my first buildings was, I'm an architect and ecologist, was a mud house, mud building, which was a cultural center in the Weinviertel, which is the wine district, to translate it, Weinviertel, in the northeast of the country, and where actually mud was a traditional building material for everything, including wine cellars, but also houses. 1950s, it completely stopped, completely, and it was only concrete. And so we got this funding to do this building to show that it is actually something that can be revived. And that stayed the only building. It didn't inspire anything else. There was no other funding. There was nothing. I would like to hear from you. I'm very inspired that you're doing this work, whether in Belgium, Germany, France, but also in the traditional mud building countries like Italy, Spain, Portugal, and so on, whether there is a renaissance of this or not. I know there is an institute in Grenoble in the university, but can you tell us if there are any buildings actually being done in mud anymore?
It's still a niche. It's not a mainstream material nowhere in Europe. That's for sure. However, there's activity going on, and there's contemporary architecture, like modern projects, like straight lines. You know, like that come into what people expect today to be architecture. So that is happening, and I think the combination with high tech. I think also it's what Yves showed. So the low-tech material of Earth in combination with high-tech production methods is something that is easier for the market or the clients to accept. And so you see like in every country you see like people, businesses popping up that do several buildings, public, private, per year. So I have the feeling that something is shifting because of a lot of reasons. It's not only the aesthetics of the like natural materials. It's also the ecological calculations, the ecological costs that are being made more and more. It's also like the people that want to have again a reconnect with nature. So I think there's different factors. It's also working on price a lot, and there's a lot of people who are working on, such as us, work to get the price down, like produce on a bigger scale to get the price down, to get more people to buy it. So there's lots of factors to be worked on at the same time, and I have the impression that something is moving. Yeah, but maybe I'm biased. But I also wanted to like pass a bit the word to Yves, how you see this connection linked with the question of how to have it accepted between like low tech and high tech. What is the role of high tech in having these kind of these softer materials accepted in our technological society, let's say?
I think the basic answer was already given, like you put it in a broader social and cultural context, and we have to change and to implement it. But one leverage we have, I think, is that we are speaking about construction costs for a building, and of course we should add the grey energy cost of producing the material and also the cost when we demolish them and we leave them. So this is in line with certain aspects which have been discussed. And I think we could get, the construction industry is not going to change like that. We have to force them to change. And we could change them if policymaker would decide that you, for instance, would win an architectural competition not based on a reference of the construction costs only, but also of these additional costs. And that's something important to push, I believe, and then earth and timber and other materials would gain in importance. And now it's mostly the clients actually who ask in projects we work on for timber, and it's not the company actually. So the construction company is very conservative. They have to get in that knowledge because the clients are asking for. So that's one answer I think I would give, which could change more. But it's true that you know, when you look around, you have 90% of concrete construction all over. I'm in a structural engineering department, so it's really in Switzerland. So this is really a business model from the 20th century. I mean, the architects actually played into that because they decided that concrete was their material to express themselves as modernist architect during the 20th century. But I believe that it was mostly a business model actually. And we are now not having a business model like that to propose. We are trying to explain a change somehow. So the economical aspect is not that much discussed, but I think it's a very important decision factor. And that's something which needs to be thought about.
A small example, in France and in Paris, they're for public projects, they're imposing a certain kilogram of geosourced and biosourced materials per square meter of new build. So yeah, that's an example maybe of policy. It's interesting to think about if that will have its impact on the society, let's say.
Thank you very much. I already heard the sparkling wine bottles will be open in the back, and it's 7 p.m. thank you very much for this wonderful discussion today, and even these wonderful lectures we have seen in the afternoon. And I'm sure there are plenty of questions we can ask now during drinking the sparkling wine in the back. Thank you very much for the concentration, and have a nice evening. And let's see us tomorrow again.
Thank you.